Okay, guys, we are getting started again. Let's wrap up the data sets. These download functions need to be refined. We are halfway there. Let me just paste the link to Discord. I feel fresh again. I've just done some workout. Super refreshing. Going through improving our download datasets functions. Okay, let me open up the live chat, guys. Can you hear me? Let's go. Let's continue modifying these functions so that we have basically the structure that we wanted. On the right side here, I'm just gonna have an already implemented dataset just to use that as a template. Okay, so we do this, we say Giosa, and we just plug in the variable. Okay, and then we go through these datasets, the URL and some keyword here, and then we request response, and if it's not okay, then I say we raise exception. And then we have a download path. We write to that download path the zip, we extract the file. We then have the, what's name? Okay, name is this word here, the first argument of the tuple, the first element of the tuple. And then let me see. Then we remove the download path. And then for file name in that subset directory, we grab that name, we open it up, we read its content. Hey Navjot, welcome in, welcome back to the stream. And then we start going through the pairs. If the length after stripping is 0, we continue. Otherwise, we grab the GRN in Spanish. And finally, we accumulate some examples. Okay? And we repeat that a couple of times, always plugging in the data into the same examples. And finally, we write down that data to the dataset directory, which is specified to be this. Okay, fair enough. Do we delete extracted files? We should definitely do that. Let me just uncomment this function down there so we can run it. Okay. Again, just to iterate here what's going on. If it's not okay, we raise exception. Otherwise, we specify a zip. We write to that zip, we extract that zip, and then we have subset directory. Okay, and then we go through the directory, and at the end we remove it. Okay, I got it. So that's where we remove the directory. So at the very end, we just have a bunch of examples and nothing in the directory, so we can just create two directions. So let's, as usual, let's just grab this logic here. Let's paste it here. And let us change the languages. So the first one is going to be Giosa. So GRN Latin, I guess. GRN Latin. Let me just double check that's indeed the language it is. So GRN maps to Latin. And the next one is Spanish Latin. Okay, so Spanish Latin. So what we're going to do here is grab this, put it here, and then basically file name goes here, and then we do what? I guess the same thing here. Same direction path here, same file name. I mean file name 2. We write, and at the end we want to copy this to the other one. So let's just do this, and let's just do copy. Again, copy the file. Let me see, what do we copy here? The original file path. So this file path, Spanish file path, and we grab the first one, Guarani, and we write it here, file name 1, and same here, we grab the Spanish file and we write it here under that same name as above, just different directory. That's it. That should work. Let's go. Let's hit run. Let's go here, F5. Let me see where we're going to download that one. So Diosa under datasets 3. Here it is. Nothing is there yet. Then we write a file, then we extract. We get parallel march. We remove the original data. We extract the zip. And then we go through aligned files. We read the contents. And again, we're going to keep on just patching data there. So we can just hit F5 here. And then we end up with what? Nothing, because we have just the data inside of the variables. And now we start creating. Now let's just write this down. The data is now written down into these files. And then we copy into this one. And that's it. We're done. GRN Latin and Spanish. What do you think of speculative decoding? I think it's a great technique to speed up the inference for large language models. I don't think you can have an opinion of a method that optimizes inference. It's just very much welcome. Okay. Kenya SMT. Corpus name. Let's replace this. Let's again go through the examples. We download, we open, and we write. Okay, and then we open it up and we keep on extending, and then we remove it. So again, we create a zip, we open it up, we read from it, we remove it, and then we end up having examples. We do some checks, and then finally we do the same logic as always. So I'm gonna keep on copy pasting, but later, after we're done with all of these data sets, we can just refactor this definitely in Latin. Okay, so the first one is Kin Latin. The second one is English Latin. English Latin. So the output path is going to be this one, followed by file name 1. And then the second one is going to be the same language direction path, followed by file name 2. And then we end up by doing a couple of copies here. And that's it. Guarani file path. This one is going to be... Okay, let's just rename this to call it source path, for example. Source path, target path, target path, target path, target path, source path. So from there we copy to here, and that's it. So we can kick this off, and I'm sure this is gonna work as expected. Let's just run it, unless there's some failure, which is kind of tautological statement. So Kenya SMT, let me open it up. Here it is, 2 directories, and files are there, all looking good. There is looks like biblical text, which is often the case when we are doing these machine translations. They use Bible as the reference, as the source of data. That's just a fun fact if you didn't know that. Okay. So I just want to do raise exception here if this fails. Other than that, we should be good. Let's continue. Translation memory from Ninorsk. Let's create the corpus name. And then let's replace this with this. Download URL. Again, if it doesn't exist, just raise exception. Otherwise, download here, open it up, extract, create a file, read from it to the data, and then delete the file. And then let me see what we can do here. What happens with the download path? Do we ever remove it? We do. So we write to it, then we open it, and then we remove it, and then we grab the data, and then we read from the data, and then we remove the file as well. Okay, and then we just do Norwegian Bokmål and Norwegian Nynorsk, 2 languages. Let's see, NLLB, Latin, and there is also the NNO, Latin. Okay, that means we're gonna copy this again. The first is NOB, Latin. The second one is NNO, Latin. We write to here, and then we just pass in file name 1. Very much repetitive. It's boring, but we are going to go through this and then start doing some fun stuff. There is some satisfaction in doing repetitive stuff as well, even though it's like machine-like. So we save it there, and then we again copy. Source path, target path, second, looking good. Let's run this. Nynorsk memories. Looking good. We are done. Latin, Latin. Okay. Next up, we have a couple more data sets. The hardest ones are behind us. This one. Corpus name. maybe. Let's replace this. And then download. If it's not okay, then we're gonna raise exception. And then we read, we create a source file. Okay, so here let's just copy our standard stuff. Let's just copy this directly here. Whoops. Let's go here. Oh my God, wait. I need to copy this snippet and just paste it here. Okay, the first file is English Latin. The second file is LUG something. LUG Latin. How do I keep track of everything? I don't know. Takes time. I don't. I don't think there is too many people who know, who have the whole FairSec code base in their minds. PB. Put it here, and then here we grab file name 2. Gradually, like anything else in life, just requires practice and consistency. So we write down the data there, and then we copy it. We write down, then we copy, and then we grab, let's rename this to source file path. Let's rename this to target file path. Let's then grab that same file, copy from that file to the second direction, language direction 2, file name 1 and 2. Awesome. And let's run this, hit run, and that will download Mukibi. Here it is. Here are 2 directions, and we're done. Let's continue. Just a couple more data sets. Umsuka. Corpora name or corpus name. Corpus name. Grab the download path. Download from that path. If it's not okay, return false. Otherwise, open and write. Fair enough. So if it's not okay, I want to raise an exception. Raise exception. Okay. And then open the download path, read the lines, go through the lines, accumulate examples, delete the file. And then again, let's just copy this. Let's change this with, this is English, this is Zulu. Zulu suffixes again Latin. Zulu Latin. And then what we do here is we grab this and we replace that with file name 1. And we replace this with file name 2. And then we just copy the data and we potentially delete something. Let's just see what. Source file path, target file path. Looking good. Should we delete anything? Let me see. Any advice? Read some of my blogs if you're interested in learning machine learning. Check out my Medium blogs on how to get started. I think that's the shortest answer I can give you, because I cannot be as verbose as that blog. Okay, let's see. So we download to download path, and then we remove it. And then we just paste in everything. Okay, so let's run this, download Msulka. Let's run. Let's see how this creates Msulka. Here it is, here it is, here it is. Looking good. English and apparently Zulu. Let's go to this one. Haitian Creole. Corpus name. Haitian. Replace this. Hey Ahmad, welcome. So guys, if you haven't checked it out already, join the Discord server and see the open NLLB project, where you'll be able to see everything. So just go to pin tabs, and here you will be able to add yourself to this document of language champions, of people who want to contribute and own their native language. So you can help our own data, or you can help just reviewing stuff. So you don't even have to be coder or machine learning engineer or researcher to help us. So that's the best way to get some information. Just check it out. Having said that, let's continue here. So download path, if not okay, again, raise exception if not okay. And then download. So this is literally a single file. So we download a path called CMU English. Okay, no, we're gonna download into, let's just copy this. Let's just do something like this. The first language is English Latin. The second one is Haitian, which I assume is also Latin. Haitian Latin, exactly. So HAT Latin. Yeah, you can be a noob like me. Yeah, just take your time. Okay, so let's save the files there. Let's save the first file here. We save it. And then here, and we do the same thing just for Haitian. And we save it. If it's not okay, we raise an exception. Otherwise, we copy the files here. And that's it. So let's call this one, for example, I don't know, like source file path. And let's call this one target file path. That's it. Let's kick it off. Run. It should download. Oops. Okay, no such file. Interesting. Let's see, where do we hit the error? Haitian. Oh, wait. Just a second. Download URL is there. We just change this. And here we want to change, oops. Here we want to change not that, but instead this, the download path. Okay, let's rerun. Let's just delete the CMU Haitian dataset. Let's delete this one. And let's rerun. Cancel, stop, rerun. CMU Haitian is where dataset 3, here it is. Here is the data. Let's continue a couple more and we are done. Beyond it. Okay, again, corpus name, beyond it, download link, download path. We download to this gzip. If it's not okay, we raise an exception. Otherwise, we extract and remove, and then we open up this file. We grab the data, English to Kurdish. We remove the tmxn, and after that, we go and we do what? We create a dictionary directory here, and we save to that directory. Let's just see which Kurdish exactly are we dealing with. I think we're dealing with Central Kurdish here or something. So let's see. Beyond it, Kurdish. Okay, I think I made a note somewhere here. Beyond it. So this is KMR Latin. We already manually checked that before. So that means that we need to do the following. Copy this. Come here. Change. The first one should be English. The second one should be KMR Latin. Okay. And then we do something like this. And then, well, actually, let's see. We don't even need this. We just save this to here. That's gonna be just a second. So we had English to Kurdish, and exactly that. This is exactly that. Goes from English to Kurdish, and then we want file name 1, and then here we want file name 2. That's it. After we were done with that, we go and copy the files for the second direction. We grab the source path, we grab the target path, and we paste in. We repeat the same process. Again, here we're gonna raise an exception if something is off. Extract, remove, and again we don't need this. We just need Kurdish and Turkish. Okay, so let's repeat this. Let's just repeat this here. Oops. Kurdish and Turkish. Okay. So first language is Kurdish, KMR Latin, and the second one is Turkish, Turkish Latin. Okay. Let's paste in this file, followed by file name, and same here. Whoops. Followed by file name 2, Turkish. After that, we just want to copy. And we're done. Let's run this one. So we expect beyond it, and we expect 4 directories. Exactly beyond it, English Latin, KMR Latin, English Latin, KMR Latin, English Latin, KMR Latin. Sorry, not English, Turkish Latin and KMR Latin. Okay, looking good. Turkish, KMR. Next up, download Ford MT. Let's see. As usual, corpus name. When I say Latin, I mean Latin script, not the language. There's over 7,000 languages in the world, by the way. And they cover only quote unquote 202. And I heard that 15 of these are not available, so that means we probably won't be able to reconstruct not even 202. Okay, languages. Download the path. And if it's not okay, raise an exception. Otherwise, grab the download path and then go through the languages. Create the source to target. Okay, looking good. We just need to map this into what? Into BCP47. And then we'll have the usual stuff. There is a ton of work to do with data here. Not available in terms of bytext, of public bytext. Okay. Yeah, I think that's work from DeepMind actually. Ithaca or something like that. It's about reconstructing those ancient languages. Basically being able to fill in the blanks. If there is a scripture that you basically scanned and there are some letters or words missing, you fill in the blanks by using some machine learning model called, I think, Ithaca. Yeah, that's cool. I definitely prefer living languages for this project, but who knows, maybe one day. Okay. So let's map to BCP47. Okay. Source BCP47 equals convert into BCP47, the source, and then we do the same for target. If source BCP47 equals to unsupported, unsupported code, in that case we do what? if it's an unsupported, then we don't want to save that. Okay, and same here. If it's unsupported, we don't want to save it. Otherwise, we create the target directory, we make it, and then we create the source path such that this is gonna be corpus name followed by source PCP47, and we grab the source one, we pass it here, and that's it. And here similarly, we do corpus name and then target BCP47, and we are done. Okay, and finally we remove all of them. Let's see. Can you translate Franiansky? Yeah, I'm not sure there. Not even super intelligence can translate Franiansky. We are so far away from that, man. So far away. If there's a monolingual data available for them, I guess they can be somehow added. Yeah, you can always mine data, right? I'm not sure what you mean by stuck on onboarding. Just basically click the types of things you want to join, and then should be fairly intuitive. But if you're still stuck, send a snapshot. Well, I wanted to say send a snapshot to Discord, but if you can't join Discord, then that makes it a bit difficult. Try and just click your preferences, and it should let you come into the server. Otherwise, you would be the only person in the history that couldn't get into the server. Okay, awesome. Nice, Ahmed. Okay, so we download a bunch of data, we convert, and it's not supported because what? Which language is not supported? Let's go here. Is it AAR? Ambiguous, unsupported. AAR is unsupported. Fair enough. That means we skip it. Let's continue, and then we again skip it, 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 because all of these are AAR. Now this one, AMH, is supported apparently with English. Okay, so that means we go and we create AMH like Ethiopian. We create the directory. My brain is not working, guys. I've been working too much, I guess. Source path, but there is no stopping. There is no stopping. AMH, okay, direction, and then the file. We write it down there, and then corpus again, and target again. Okay, let's go. Let's see whether we hit any other unsupported ones. Otherwise, we can just continue. That's it. For an MT. Let's find it. For an MT. Here it is. And that's our data. Nice. Nice. Okay. 2 more to go, and then some refactoring, and we are snapping done. Meaning NLP. I swear to God, if I write down once more corpus name and then the name here, I'm gonna freak out. Direction, min Latin, ind. Why would you just leave ind? Why not just specify it immediately? In Latin. In Latin. C and I don't see anything else, but let's just double check. Let's just double check that int is indeed in just a single language, Indonesian, and it is Latin script. So let's go and make it in Latin. Okay, and we create it, and then we do what? Then we grab it and we save corpus name Latin. We download it. If not, okay, let's raise exception. Same here. Download it, corpus name, and we need put language code 1 here is going to be in Latin, and then language code 2 in Latin, and then I'm just gonna do it like this again, just language code 1 followed by language code 2, and then followed by double quotation mark, and then language code 1 here, and then language code 2 here, and we're done. Just remove return statement, add raise exception, and that's it. Now again, the question here is, do we want to copy in both directions? What's so special about having this as source train, target train? Okay, just leave it like this. Download AAU is the last one. Wait, we didn't run this one, right? Let's just run this one. Let's make sure all is good. Run. Minang NLP. Here it is, looking good. And finally, so this is in Indonesian and whatever the min language is. Okay, final function, and then we can do some refactoring. So again, corpus name, direction. Okay, there's a ton of directions here. Back to the thing of unavailable languages, if I remember correctly, they did mine by data using laser, but they've also added some to the data. That's true, Ahmad. They did mine it, but I'm not sure. Does the mine data cover all directions? I'm not 100% sure. I actually have the data. That's like 450 gigabytes. LNAI folks basically created and shared it with a permissive license on Hugging Face. So in one of the previous streams, we actually played a bit with it. Okay. What does this function do? We're almost done. Almost done. This is a long file. We literally went through the whole file today and edited most of the things. Let's see what exactly is it that this does. So it opens up the download path and then goes through the URL list. Let's just throw an exception. and then we write to the file, and if it's okay, so we basically write to this particular file. So that means that file has to be in the right format. Download path is gonna be corpus name followed by what? AMH Latin. No. AMH Ethy. Okay, let me just see one thing. Okay, seems like that one is supported. We can just add the script Ethy and then English Latin, and then here we just store it like this. Okay, maybe let's start adding codes. Language code 1. Language code 2. Whoops. Latin. And then just make this an F string. Pass in the first code. Pass in the second code. And here pass in the first code. Looking good. We save it there. If not okay, then we basically raise an exception. Let's go here. Again, this is just corpus name followed by language code 2. Nope. Language code 2. Let's continue. Here, raise exception. Let's do the same thing here, just for different languages. Again, first one is going to be English, Latin, and then there is the ORM. ORM is what? Maybe ORM is one of the unsupported ones. Let's see. ORM. Okay, ORM is a macro language. ORM is a macro language. Let's see whether I noted which dataset. I did not, but I don't think we had ORM so far. ORM. Or we did. Okay. Fair enough. There is an assumption we can make that this ORM is always going to be GAZ Latin. So let's go. Looking good. And then we want to have language code 2 here. Whoops. Let's just put language code 2. Okay, and then raise exception. And let's continue. Third language, English and TIR, which is Tigray, I think. So English, Latin, and then the second one is TIR. Well, which one? Can we just assume this is Ethiopian variant? Corpus name followed by suffix, and then corpus name followed by suffix here as well. Just put 2 here. And that's it. If not okay, raise an exception. Delete this. If not okay, raise an exception. Fair enough. This should be good. This should be good. The only thing I have to double check if whether we are dealing here with Ethiopian variant. So let's just go and open up this one. How the hell can we know whether TIR, okay, TIR, we assume that it's mapped to TRI Ethiopian. Okay. Sounds good. Let's run this. And we are done, guys. Some refactoring after this. I think this was a good chunk of work. I'll try and add some support to download NLLB seed as well. It's gonna make our life a bit easier rather than having to manually download it. Let's run. Okay. AAU. Here we are. First things first, create this one and then download and then raise exception if not okay. Raise exception if not okay, raise exception, raise exception. So exceptions are good. Let's see just the language codes. Language code 1.2, corpus name 1.2. Language code 1.2, corpus name 1, corpus name 2. Language code 1.2, corpus name, language 1 code 1.2. Okay, looking good. I think we can just hit F5. Okay. And here it is. That's it. Almost there. Now left to do a couple of to-dos. Make sure I didn't mess up the code. Oops, let me just return this back here. Let's do some refactoring. First of all, I keep on doing this same boilerplate code, which sucks. So let's just grab one up there. Okay, let's grab one like this. And let's just say init routine def and then this. So basically somebody has to just pass us the corpus name. Given the corpus name, we create we also need directory. So given the corpus name and the directory, we create that directory and we print saving corpus name data to directory. Okay, this is repeated all too often, so let me just start replacing these parts. Basically just passing directory and corpus name. Still sounds good. Or no, sorry, we need to actually have specified the corpus name because we're going to reuse it down the later in the body of the function. So something like this, and we can literally now replace all of this boilerplate code. It's always the same. We create, we make directory, we say, we print. Let's just keep on replacing this. Let's move this helper function somewhere above, like here. Okay, these are just some helper functions. These are just some helper functions, and then end of helper functions. Okay. Sounds good. Okay. Let's continue. Same thing, just Tico. Tico. Same here, just indic NLP. Lingala songs. FFR. Okay. Saving 2 lines in every dataset, but more importantly, making it easier to update the whole thing if we need to do that. Okay. Couple more. Okay, That's the first refactoring. Let's just make sure we've done it correctly everywhere. So here, good, 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 good here, here as well, here as well, here as well. Same here, same here, same here, same here, and here, and here, whoops, and here, and here as well, and here as well, here as well, and the last one I think, or almost, and here as well, and the last one TIL. Okay, so that's the first step. Okay, now for the second part. So I kept on reusing these, creating language codes and then creating all of these same ones constantly. So let's see how we can refactor this a bit. I don't think we need more than 10 more minutes roughly to wrap this up. Optimistic. Okay. Let us see. Okay, this part. Language code. Let's first see where I messed up something and then we can refactor. AMH Ethiopian, English, Latin. Let's close this. Close, close. Open the diff. Okay. So here we had English and TIR. Okay, English and TIR. That's good. Let's continue. Then we have English and ORM. English and GAZ Latin, because that's just how we ORM maps to GAZ Latin, because that's the only language that we support in this macro language group. Again, just to double check that quickly, ORM is mapped to GAZ Latin. Okay, fair enough. Back here, open it up. GAZ Latin. The first one is English, the second one is ORM Latin. Let's go. AMH English. AMH English. AMH English. Good. Okay, let's continue. Then we have Indonesian and Min. This is good. Let's see for the Horde MT. Did I change anything other than corpus name, source and target? Source and target. Okay. Word empty, looking good. Okay, here we had Kurdish and Turkish. Kurdish and Turkish. Kurdish and Turkish, looking good. English and Kurdish. English and Kurdish. First English and then Kurdish. Okay. Looking good. Let's continue. Haitian, English. So first English and then Haitian. English and then Haitian. English and then Haitian. Looking good. Let's continue. English and then Zulu. English and then Zulu. Okay, looking good. Here we had English and then LUG. English LUG. That looks good as well. Here we had NOB and then NNO. Looking good. Here we had KIN followed by English. Looking good. Here we had GRN followed by Spanish. GRN, Spanish, okay. Here we had English and AKA, okay. Looking good as well. Here we had French and Iwi. French and Iwi. That looks good as well. FON, FRA. I can't spell today. That's looking good as well. So FON followed by FRA. And then here we have what? English YOR. English YOR. That looks good as well. Here we had English and XHO. English XHO looking good. So again, English. Okay, let's continue. Then we had okay, these I saved before already, so I'll have to double check these without the changes. Okay, let me close this down. This so far it looks good. Let me just see whether potentially I messed up something. I'm gonna compare that with the using some old data. So we need AKA and English. Okay. French and Iwi for French Iwi. French and Iwi, looking good. FON and French. FON and French. Sounds good. English and your menu 20K. English and your. English and XHO in this data set. So let's see English and XHO. Okay, that looks good as well. Let's see this one. Okay, here there is a ton of these, and then we just make. So we just convert to source, and so this should be okay, because here we are just using source and target, source and target, source and target. FFR, FON, FRA, okay. Lingala, FRALIN. Let's open up Lingala, FRALIN, okay. Indic. I guess for indic there is nothing to screw up because this was special logic. And then Tycho, again, nothing to screw up here because it was special logic. And finally, TIL. Nothing to screw up here, special logic. Okay, guys. So, one task less. And let's just refactor. The last component is to just reuse some of the functionality that we've been copy pasting all around the place. Let's first save this. Okay, this is Stokes. I'm looking for versec. Git status. Let us store the non-YAML. So this is the only file. Let's copy, let's add it, and let's commit it. So refactor all of the primary datasets download functions. Push to origin. Okay. And we're good there. Final to do is to reuse some of this code and just make it a bit cleaner. So let's pick some of these functions. There's a ton of these download functions because we have a ton of different data sets. I think we cover, with these data sets, we cover around 96 languages. Just FYI. Okay. FON French. I think this is one representative example. So we always do this. And then we almost always do something like this. Source and target file path. And also, okay, we don't have to do this because we already have done it above. This is a small bug, and we wouldn't have that if we were just doing this every single time like this. So codes, file names, directory names, maybe like this. And then source file path, target file path. And then copy source file path, target file path, and then we basically delete the download. This is a common pattern we've seen, and we can somehow create a wrapper function that will do this exact thing. And then you pass in your custom logic inside here. Okay, so let's grab this as a template. And let's try and squeeze in a couple of other ones into this template. So let's call this like a wrapper function. Find, download, by text, helper. Basically, given a particular function, we're going to define, let's call it like this for now. So what we're going to do is always do this. We're always going to do this. And then this is a special thing you do. Actually, just a second. You pass in a function and we return back a new function. So this is your core function, and we basically pass some arguments to your core function, like source file path and target file path and download path. And then we write this. And then we return that function. Let's call this wrapped function creatively. And this is the core function. So we have to obviously pass in corpus name, language code 1, language code 2, dataset directory, download path. Okay, something like this. So with this, I think we're gonna improve the visibility and reduce errors. That's the expectation. So let's see how we can apply the function to here. Just a second. Okay, let's see. So we just need to pass this. We define a core function here. This is going to be the core function. Core function does what? This. So it needs the download path. Everything else is a boilerplate code. it needs a download path to read from that. It needs the source file path and target file path, and then it reads from the file, reads the sentences, and writes to those files. That's it. That's everything this function needs. Okay. Print, wrote, copy, remove, print. Okay, so this part is the same. And this part is the same. So what we need to pass. So once we define the core function, let's call this. And we pass in the core function download path, dataset directory, corpus name, len code 1, len code 2. Okay, and we just execute it. Okay, so this is going to take this, wrap it up into the boilerplate code, and then execute the whole thing. So we don't need to construct none of this. This is constructed internally. This is not needed. This is also not needed because we pass in this. This is also not needed because we pass in the corpus. And the only thing we need is to specify the language code. Which means something like this. Okay, guys. So this is our refactored function. And so now we're going to have much less code because of this, and less errors because every time we're going to do the same thing as opposed to copy pasting. Let me see. Let's call this one core function wrapper. That's it. So let's see how this is gonna improve the readability here. So instead of all of this code, you replace it with just this. Something similar to this. Let's see. Whoops. So language code, always the same. Corpus name, language code. We can delete this. This is always the same. And this is always the same. We don't need none of that. We also don't need the paths. We also don't need to say write and this and remove. This is all we need. We just say core function is this. The logic is like this. And then just call this. That's it. So here the language is this, language is this. Okay, download path is in this particular function not even used because download path we've already written down the data, I guess. Okay, here we, just a second. The difference here is we have to pass the source file path and target file path as usually, but this time, instead of the download path, we have, okay, maybe, just maybe, we can wrap all of this into the core function and then it's the same. Okay, I think this is it. This is the core function. Looking good. So we again squeezed in, we again have the same logic. Right? The output of this one is, so the input here is download path, and we end up with French examples and EB examples. So ultimately the input is this, and download path. This should work. And we just specify the languages, okay? So we can delete all of this. That's it. We can potentially even move some of this functionality into this format. Okay. Let's quickly test these two functions so that we didn't screw up anything. Let's just see and make sure this makes sense. So corpus name French fongb. Corpus name French fongb. Let's delete this one. Or let's just rename it to French fongb2. And let's run French fongb. Will this run as expected? Hit run. Enter here. Enter. Wrapped function. Okay. So file name 1, file name 2. Create these. We called for the core function. We just reads the data, just reads all of the data, exit, and then we say wrote, and then we say copy, and then we say remove, and then we say deleted, and that's it. Yes, looking nice. Let's see the French iwi. French iwi. Again, let's just rename it to 2 so we can compare it. Let's run this one. Okay, it's downloading the data. And apparently it worked. So that was French iwi. Here it is with data looking the same as here. Wait, French iwi, iwi Latin. Okay, this is good. This was actually bad because before I had some bug. Okay. Let's continue applying this patch. Let's keep applying the same logic. Let's just grab this one here. It's cleaner. And let's go to the next one. Here again, same logic. We have model name. We can remove all this. We can remove this. We can remove this. We can remove all of these. This is the core function. Actually, it looks literally the same as this one below. Almost, if not the same. Let's see. Create a core function. And then call this. Okay. Is this literally the same? Download path, yes. Open source file path as source, open target as target, for line in CSP lines, blah, blah, blah. Yes, yes, yes. Literally the same code. Exactly the same code. Nice. This one is a pass function. Let's continue here. Again, here I see the same logic. Let's copy our template. I just use it so that I know the structure so we can refactor the original file. So again, we don't need any of this. We don't need the file here. We don't need the file here. We don't need to copy. Okay. Examples given a download path. Okay. Let's see where we can put this. So we get the response. This one is a bit more complex because it's running in a for loop. Let me see what it looked like before we started pasting this. So this is outside of the for loop. So we first finish the for loop to get the examples. And only then do we write Okay. Let me see. What do we want to do here? We want to wrap this whole thing basically into, okay, we basically want to do something like this. Language code, grab all of this, or no, wait. Yes. Let's just replace this with source and replace this with this. And then let's remove this. And let's move this whole thing under the core function. Okay. And then this whole thing here. And then after we have this, we just run this. We can pass in none because we will not be using this one. Okay. So here what we do, download, blah, 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 collect the examples, and then just write to here. And once you have written there, let me see whether the rest here will work. So this wrapper, this part will work. Then we run the core function, that's fine. And then we copy file. Is that how it looked like before? Did we have copy file here? We did. We had copy file in the down below. So we had copy file, but we did not have remove. Okay. So if we pass none as the download path, if we pass none, then in that case, only if the download path exists, if it exists, then we call it. Okay. This should be, this one was a bit trickier, but still worked nicely. Let's just run it, make sure we didn't make any silly mistake. So this is Giosa dataset. Let's just rename it to 2. And let's rerun it. Hit run. Here it is. let's just run meld directory comparison. Just quickly compare copy path and copy path. Let's see, compare. Have no differences. That's it. Completely the same logic. Okay, guys, let's continue. Download Kinia. Again, let's just grab this template. Kinia. Similar logic here. This looks very similar to what we've just seen with Gyosa. So now we know the trick. Now it's going to be easier. So just keep the languages up there above. And then remove all of this boilerplate. Remove this as well. Remove the print. Remove this. Remove the print. Remove this. Just rename this to source file path. And this to target file path. And this whole thing now is core function. Download path. Source file path. And target file path. We wrap this inside here. And then we call this download path none. And that's it. That's the logic. So again, this is just going to create those paths. This one is just going to write there. And then we're going to copy them and potentially delete stuff. That's it. Next one, I think this one is going to be more susceptible than the previous ones. Let's see. Again, copy the pattern. We don't need anything here. We don't need these. We don't need this. We don't need this. Let's just rename this to source file path. Target file path. We don't need any of this. And pass in the data. Where is the download path? Here it is. So given the download path, we just need to wrap this exactly. And then we call it like this. Core function wrapper. We pass in the download path. And then it can do its thing. And that's it. As simple as that. Remove this. and remove this. Let's go here. Here it's gonna be even easier. Did we have remove here? Wait. We might have made a mistake here. Wait, this one has to be obviously outside. That was a mistake. And then let me see whether whether we had the delete function. We just had copy. Okay. Because what? Let's see, download path. Wait, where did we delete it before? Okay, OS remove. Okay, then don't remove this. And you can remove this. Okay, so what we need to do here is not remove the download path in the core function and leave that to the outside. Whereas this one, just a second. Download URL. We download and we have the path. So we open up the path and we write the response there. Aha. Where are you gonna get the response from? Wait. Okay, it should actually work. Let's just pass all of this in here. Nothing bad will happen. Just a second. Will this work? I think it will. The only thing is we pass in the response not through arguments, but through the global, through outer scope, which is not the nicest thing. And also dataset directory. Wait, what about here? Dataset directory. Download path. Not sure what's the best thing to do here. Should we just pack in everything inside here, but then we're gonna ruin the pattern. Dataset directory. Also here, let's see. dataset directory. Download path. And here, dataset directory is used to construct the data path. But then we reuse it again. Okay. Let's just test it. So that one is Ninorsk memories. Let's go here. Let's rename this to 2. And let's rerun this. Hit run. And hope nothing crashes. Okay. Unexpected indent. Where? Where do we see the unexpected indent? Okay, here. Okay, that's just the last function we've been handling. That's still not over. Okay, let's just hit run. I mean, that's fine. Okay, here it is. Again, I wouldn't be surprised if it should be completely the same. Okay, looking good. It works. The thing I don't like is that sometimes we pass the arguments through the function call, and sometimes they are just taken from the outer scope of the function. That's not the prettiest of designs, but I think it's still much better than having all of this boilerplate all around. So like, let's just look at how much we can save. We just delete all of this. We just delete all of this. We delete all of this. We delete all of this. Just a ton of code is saved. And the only thing we have to do is pass this. So here we just do this. And then we do this, and we do this, and we are already done. That's it. DSP, source, target, we read, and we write. And at the end, we just call this. That's it. We save a ton of code. Hi, Eugene. You don't need to know anything about spectral methods. I think it just depends what are you going to do. I think it's a fairly separate and standalone area of GraphML. That would be a TLDR. Okay. Let's see how we can clean this. Again, we don't need this. We don't need this. We don't need this. And then I think we just need this. Something like this. And then wrap this into a core function. Core function. Exactly. So given the download path, we'll open it up. We read the data. We fill in the data here. We remove the download path. Nope, that's not going to be done there. It's going to be done in the outer scope. And then we write, and we are done. That's it. Much cleaner. So only that one was very bothersome to figure out what's the nicest of designs. This one is clean because this one just uses download path, opens the file, reads the data, and then reads from that data, and then creates local variables here. And these examples, okay, well, in reality, we should have these examples here. And that's it. I think we had some similar examples where I left this outside, but it doesn't matter as long as it's much more concise now, like this. Okay, let's go to Haitian. Is this similar logic? Yes, it is. Of course it is. So let's delete all of this. Let's delete this one uses a bit of different logic because it uses this download file function, which does the following logic. Grabs the path and download URL and grabs a response. No worries, you're welcome. So let's see how we can do this. Source file path. We can download the URL instead. Okay, so I think it's kind of similar, not the same. But if we do it like this, and then do it like this, and then just call this a core function. Core function. And instead just call this download URL. This will work. The problem is it's gonna try and delete the URL, which will fail, as there is no need to download because this one will get response right there to the download path, and then that's it. We don't have to delete anything. Let's just see if we just do this. And we pass in the download URL. This will work with a caveat that we have to, if it exists, or we can just do try and do it. If it succeeds, otherwise just pass. That's it. Or okay, maybe we can leave the guard. Download the path. If it exists, then we try and remove it. Sometimes it will fail because as we just saw, because of this example where we are passing URL. Okay, let's continue. Beyond it. Okay, a ton of repetition here. Let's see how much we can delete. We can delete all of this. We can delete this, we can delete this, we can delete this, we can delete this. Okay. And then download path, languages. Let's just put the languages up there. And given the URL, we download the path. Okay, we can make it like this. Let me think. We can make this whole thing a core function. Okay. And then rename this to source file path, this to target file path. So we can just pass in none here, and we don't have to use this at all. So just grab this one here, download, extract, open, remove, and we can pass in none here. No need to pass in anything. And that's it. Much cleaner. Let me just think one thing. We can optionally pass in the download URL if we want, but then yeah, I think it's better to do it like this. Download path. From that URL, we download to that path. Okay, this will work. Let's go here. Again, delete all of this, delete this, delete this, delete this, delete all of this. Move the languages up there. Define this as a core function. Again, we can do something like this. Source file path and target file path. And then wrap up this whole thing inside of here. And then just rename this to be source file path and target file path. And we are basically done. We just need to call this and pass in none. That's it. Much cleaner. Let's see this one. Okay, this one won't need it because it's a bit different pattern. Download the path. We go through here. If it's unsupported, we continue. Otherwise, we create the directory with the language direction. We create the source path and we just copy file there. And we copy file there and then we remove the files. Okay, so initially it just downloads a bunch of data. It goes through the languages, it downloads all of those to the download paths and saves those here. And then it copies them to this directory we just created and then removes them. That's cool. Okay, let's see here. I think similar thing goes here. We create a directory and then we save it. Sometimes we just use those two files to create a single direction. Sometimes we create double direction. I'm not sure what's the consensus there. Should we always have double direction? In that case, we can shoehorn this into the same template. Let me think. We download URL download path. We download that file here, and we download this file there, and that's it. Do we want to copy it? I'm not sure. Okay, that looks good. And finally here, again, I think we can leave this as it is. That should be good. Okay, I think we can now test all of this to see whether we maybe made any mistakes. This is in that same pattern. That's good, that's good, that's good. Let's see this one. Okay, let's see a couple of these above ones. Do we have to, okay, here we have same template. Let's just wrap up these leftover ones. So again, we don't need none of this, none of that, none of that, none of that. And then download path. We can just put languages there, grab the download path and pass it in here. Create this a core function. Download path, source file path, looking good. And then just call it like here. Much shorter, much more concise. Let's see. Again, we just leak from the outer scope the response content. That's not ideal, but I don't care. Open right, okay, and then there might be one problem here. Let me see whether we are deleting the file unnecessarily. TSV lines, we open the download path, we write the response. This can be outside as well. And then here we open it up. It's actually the same pattern as down below. And then we delete the download path. Do we want to delete the download path? That's the question. Previously, did we delete it? Let me just copy this. Let's save it. Let's copy. Let's see the diff. Let's go up there. Okay, here it is. Did we remove it? Yes, we did. Here it is. So above font French. This function is above font French, right? Font French. Yep. Okay. We want to delete it because that's just train TSV. Okay, that's good. and let's see a couple of other files. Similar logic here. Not quite the same. Because we have to rename from the extracted. Okay, this is a bit, I'll just skip this one because it's too peculiar. And we wouldn't save too much. I'll just leave it as it is. Let's go to this one. Here as well, leaving this one as it is. This one is perfect for refactoring. So we can delete all of this. We can delete all of this. And just grab the download path like this. Let's extract the code up there. And then this goes into the core function. Core function. Exactly. And then we just need to, FON is the, now we need to be careful here. What's the source? What's the source? French. So the second one is French. Okay. This one is a bit different. Because we open the download path and then we open up these paths as well. Why not just, okay, we could probably reform it into a similar shape, but I'm not gonna do that. Let's just make sure we don't mess up the order of operations. Okay, let me just go back quickly. Let's quickly go back. So here we have what? FON, which is the FON file name, which is the line code 2. Going as first. And the second one is actually this, which is first. Okay, so we swapped there. Okay, let me just go back here. All looks good. We just have to change the order of the codes. And this should not be good. So we can just call these source. You're the source and you're the target. And remove this. Okay. After this, we can just call the function, the wrapper function, pass in the download path, We grab the download path, we open it up, we write the response. Again, just some leaking from the outer context, but it's fine. And then source file path, target file path, we just write there. At the end, we're going to attempt and delete this file, which is, I think, legit because we want to do that. Let's just see whether before they've done that as well. So go here, find that function. Here it is. Yes, we were removing the download path, which was again this dataset. Okay, looks good. Lingala. Same pattern. Lingala has the same pattern. Remove all of this, remove this, remove this, remove this, remove this, remove this, remove this, and then this goes above here. Download path. We can just wrap up all of this inside of the core function. Exactly. And then this is going to be the source one, and this is going to be the target one. Okay, we open up the download, leaking there, and then open it up, read, collect the examples, and then write them. And finally, we just call the function here. And at the end, we delete the download, which is the old data, which is good. Okay, that's it. Let's just see whether before we had deletion as well. Lingala songs. Before this, we had remove delete as well. Awesome. Indic, I don't think this one will be able to. Yes, this one is very special. Tico. This one is also very special. Because we are mapping languages from above, so it's not the same pattern. And finally, TIL is also special, so we will not be refactoring it. And with that, guys, this is completely refactored. Let's just test it quickly. I think we saved a ton of code. This was previously like at least 300 lines of code more or something. We can remove all of this. Let's rerun it, and then let's just add a validate function. Given a directory, we're going to go there. Let's just go up. Let's define the helper function here. Dataset directory, let's just call it directory. And we are going to iterate over that directory. Okay, so let's go for corpus name, exactly. Corpus path is this, and then we go through corpus path. So for language direction in corpus path. We do what? We double check that the direction is good and the suffixes are good as well. So let's create language direction path, corpus path followed by language direction path, exactly. So we make a couple of asserts. First things first is break it down to this and this, and then assert that source is in that it matches the BCP pattern. So BCP match the regex. Okay, let's go to validate. So we assert that this code matches the regex. Okay, and then do the same thing for target. And then we go and iterate for files. And for each file, we extract the suffix and we assert that this is also a BCP code. And that's it. So we run this at the end here. Makes sure that the data sets are in the expected format. See the script header. And in the script header we say this is the required format. We have to have corpus name followed by the BCP code 1 to 2, and then underneath it corpus name, and then this. So actually we want to also check, wait, let's add that additional constraint. So the suffix, and then there is the prefix. Prefix is this, and we want to assert that the prefix equals corpus name. That might be to get the actual corpus name. Yes, that should be, that's right. I think this is right. So both the maybe prefix first and then suffix. Okay. Let's go. Let me open up my launch.json. Let's go to download primary data. Let's add 4. We keep on iterating here. Let's go to download data. Where is the script? We can delete this datasets 3. Just send it to trash. Delete. And run the script with all of these enabled. And at the end, run this one as well. Maybe we can run this time, just this time. Let's run this. So we can fail fast. Not the most optimal because we'll be checking many of these directories multiple times. But as I said, I want to fail fast in this example. Oops. Wait. Okay. Let's run. Kick it off and see what happens. Hopefully no errors, but maybe we will have some errors. I don't know. I was fairly pedantic and careful, but sometimes errors creep in, so let's see. Okay, it's downloading. Let's see whether and where do we fail. But this was just a tremendous work today for the primary dataset collection. Tomorrow we're going to understand why does the filtering pipeline work the way it does. There were some discrepancies there, so I want to double down on that. And after that, we're gonna continue to the prepare data stage. And then we are ready to start working with mine data. Let's make a short break while this is downloading and see how it goes. So it's 5 gigabytes now. Let's make a break, maybe 3-4 minutes, and I'll be back. Just gonna stretch my legs a bit and see how this goes. Okay, guys, it looks like nothing failed so far. Nothing failed so far. Looking good so far. Let's wait for that to finish, and we are wrapping up with that tonight. We should maybe try and download NLLB seed as well. Just add it in another function that's gonna do that, so that people don't have to go chase different data sources. They can just run the script and everything is gonna be ready. Okay, we are at TCO dataset. Let's leave it to run, and while we are waiting for that, let's see. So this is done. And then tomorrow, as I say, filtering. Going a bit through the analyze and visualization scripts we made. And then slowly progressing towards the end. This is the kind of, I think of this as a second pass through our pipeline. We initially got it to work, now we are robustifying every single component. And then we're gonna just increase the amount of data on the input and start training bigger models. For that, we'll already need more compute. As this work is slowly, as this project is slowly getting more people enrolled, I think we're gonna have stronger arguments for why would somebody give us a grant and what we're trying to accomplish here. Are you guys enjoying this? Are you learning something? Are you just, by seeing how I'm thinking about code design and all of this, is it useful, at least somewhat? I'm gonna keep on doing this no matter whether people find it useful, but I know somebody at least will find it useful. I'm not sure, like maybe beginners, I don't know. Okay, here's one error. Let's see where that happened. Expected indic NLP to be wiki matrix. Corpus name. Prefix. Oh, okay. This is actually fine. It's just that I name all of those files indic NLP, or maybe, let me think for a second. Maybe in the indic NLP, let's go to indic NLP. When we are renaming the files, we can, so this is not an error. It's just more of my design decision here. New file path. So this is where we rename the file path and then we rename the directory. So in this moment here, I've chosen corpus name. And what we could have done instead is we should have instead maybe added the name of the child data path. Let me see, language direction, blah, blah, blah. And then we rename this to this. And then we move this child dataset path element. So the name should be element if we want to be precise. So maybe something like, in this particular case, element and then corpus name. Actually, if I do that, then I don't want to do that. Let's just keep it element. Okay. So with this, let's repeat the run. Let's just stop this. Let me comment out these two. Let me rerun the indic. Let me just delete it. So indic NLP datasets 4. Oh snap. Tico and till. All of these should be deleted. Just move to trash. Ted to alt. Just delete them. And rerun. Rerun. Let's just make sure we put the breakpoint here. I think over 10.5 hours of streaming today. That was crazy. That was... I maybe had a couple of more days where I was streaming over 10 hours. Usually around 10 hours. Almost done. After indic NLP, all of these are smaller ones. Let me see. This one, all of these are smaller, I think. Menu. Maybe one bigger one might be Horn MT. But I'm not sure. Okay, almost done. Almost done. Extracting, I guess, in the background. And we're gonna slowly start. Okay, here it is. So Wikimatrix, exactly. Let's just hit F5. And we're done. Looking good, looking good. Why do I have breakpoints there? Just keep downloading. We're at French EWI. We are here, progressing through the pipeline. This is just so much cleaner compared to what we had before. Giosa, we're done. Kinia SMT, we're done. Ninorsk memories, we're done almost. We're now here. A couple more data sets. If there are no failures, then this was just perfect. Unsuka, Bianet, we are here. OrnMT, we're here. And the last one, and we are done. Guys, this was just amazing. Look at this. Now every data set has precise structure. This is just super clean. At least the structure, the data itself, we'll have to see about that. But that's it. That's it. Now I'm gonna quickly uncomment this one and delete every intermediate validate call. We don't need those after every call. Okay. Delete this. And validate here. Tycho. TIL, delete this, and that's it. We're done. Let's see what are the changes. Let me just see whether I'm calling still all of the data sets. Yes, I am, I think. Tico, Indic, Lingala. Okay, looking good there. Add the validate. Okay, just a ton of refactoring. Nice. I guess the run being successful is the ultimate test. Let me just see whether any insightful messages can be seen here. Row deleted, row deleted, row deleted, deleting this piece of data because it's not supported. Deleted, saving the data, row deleted. Looking good. Indic NLP, Tyco, row deleted. TIR, so we deleted the Eritrea variant of Ethiopian, and -1 language is unsupported. Deleting this piece of data. Okay, that's just a small bug. Okay. Let me just see unsupported. Return the unsupported code. Let's just replace this with actual source. And same here with target. Just to avoid that printing of -1. And that's it. Looking good. Let's save this. Let's push these changes. Let me just exit scopes. I keep on opening that one. I don't need it. Here sec. Git status. Git add. Last commit of the day. Copy. Save it. All of the other ones are YAML. Commit. Complete refactor of download funcs plus validation. Check. Push to origin. Okay, my name there, and then let's just type in this, and that's it. Awesome. Guys, this was very productive. Finally, the pipeline is ready. Let me just notify people. Going forward, you can just run the download script. Let me just update the README actually, because now we don't have to use this modify dataset structure function anymore. Okay, actually for NLLB seed, we need to add additional function, and then we will not have to run this anymore. Let me just add the to do. A quick mention, I have some wedding tomorrow that I have to attend because I promised to my friend, I think a couple months ago. So that means I'll have a bit different schedule tomorrow. I will let you know. I'll start streaming probably very early in the morning, around 9 a.m. already, and then until maybe like noon, and then after that I'm going to wedding, and then after the wedding I'll be streaming again. So it might be a different schedule, maybe a bit less hours. Maybe I'll pull out 8 hours tomorrow, but that's just FYI. Cheers, guys. Have a good night. Have a good day wherever you are, and catch you soon. Cheers.